Hello student, welcome into our first lesson on fluid flow, and in this topic we are going to learn about the turbulent and streamline flow. And to start with, I wanted us to start with the streamline flow, and this one represents the two types of flow. As the fluid flow, or as the gas or liquid flow from one point to the other, they exhibit either streamline or turbulent flow. I want us to start, so welcome. A fluid refers to any substance which is capable of flowing due to pressure difference, and it includes both the liquids and gases. Types of flow. The flow of a fluid can be classified as streamline, whereby we have the flow which is steady, laminar, or turbulence. Streamline or steady flow. I want us to begin with this one here. Streamline flow is a flow in which all the particles of a moving fluid passing through any given point follow the same path or line as the particle that passed through that point previously. These particles of the fluid have the same velocity. So what we mean here, we have what we call the line of flow, and of course this is the path that a particle follow as it moves from one point to the other. And if this is a particle here, if it moves toward this side, it will follow a certain path, and that path is the one we are calling the line of flow. It will flow this way. So if we have now another particle flowing from this point toward this point, and then it follows the same where this particle is following, then that flow is the one we are calling streamline. So it means that all particles in streamline flow follow the same path. Then streamline flow happens only when speed of the particle is low. Otherwise, we'll have other types of flow. A streamline refers to the path followed by the particle in a streamline flow. It is represented by a line with an arrow. This one now. Streamline flow has the following characteristic. So in streamline flow, they exhibit the following characteristic. The first one is streamlines are parallel to each other. That is one, so they cannot meet at any point. Then another characteristic is streamline flow is smooth and steady. So there is no formation of what we will see later on, the ones we call the eddies, the eddy currents. So in streamline flow, there is no eddy current. So if we have this body cutting through the streamline like this way and moving towards this direction, as you can be able to see, the streamlines are uniformly distributed. They are not meeting at a point. That's why we are saying they are parallel, these ones. And a body is said to be streamline if its shape does not affect the distribution of streamlines behind it. As you can be able to see, as this body flow from this side toward this side, this is the direction of motion, the streamline at the end, these ones here, the streamline behind this body, they are not affected at all, but they are still moving, they are still uniformly distributed here. And the effect of distribution of streamlines behind it, it means that they will flow in a streamline flow. They will not affect the streamlines here. And such objects include like cars, turbojets, birds that fly, fish, etc. So they are streamline bodies. They easily cut through the low fluids, as you can be able to see this one. And therefore, it means that there is reduced formation of eddy currents behind them. we are going to see later on what are the eddy currents. And this reduces resistance as they move. So it means they move steadily. It is also important to note that streamline flow is only possible when the flow of a certain fluid is within a certain velocity. So it means that streamline flow is only possible within a certain velocity, and that velocity, the maximum velocity under which we have the streamline flow, is what we call the critical velocity. Beyond this critical speed, there will be formation of what we later on see the eddy currents, and therefore we will not have a streamline flow. Then let's go to turbulent flow, and this is a flow in which the fluid or the particles of a fluid flows in a disorderly way. They don't follow a certain pattern. And it is a flow in which the speed and direction of fluid particles passing at one point changes with the time. It means that it is not like the streamline flow, where we saw that the particles of a moving fluid will actually follow the same path at every point of flow. But in this case, the particles may be on the same level, but they are not moving with the same velocity. And even the direction is not the same. Turbulent flow generally occurs when the speed is high and where there are sharp bends along the tube of the moving fluid. And this also means that the streamlines are not continuous. They are not straight lines. Not only straight lines, but they are not steady. There are some points whereby the streamlines are almost touching one another. And particles do not travel in the same direction. And also they don't have the same velocity. Therefore, in turbulent flow, streamlines are broken into ripples, which results into disorderly flow. These eddies have a drag effect on the body moving through the fluid, i.e., or that is, they try to pull the body backward where it is coming from. So that marks the end of our lesson today, and hope you have gotten the best out of our lesson. It is important also to just revisit not once but several times, so that whenever you don't understand, just understand even in a better way. And I have some assignments here for you, so welcome. Just try to do these examples or these assignments, which will help you even understand this topic in a very good way. And whenever you don't understand, it's always good to consult. Talk to your friends, talk to ColorNet, which is very open for questions. You can just visit us. And as we said, you're supposed to create a student email. You can even post your questions there. And we as ColorNet, we are always, as we say, we are always ready to help you, the learner. So that marks the end of our lesson. Let us meet in our second lesson. Thank you.